Hi guys, today we're going to talk about rational exponents. All rational exponents are fractional exponents. Rational meaning ratio for a fraction. So we're going to deal with fractional exponents for variables and for whole numbers. Okay, the first thing I want you to do is grab a calculator and type these four into your calculator. Now, as you saw on the previous slide, make sure that you use parentheses with the exponent. So for instance, when I type in 64 to the 1/2 power, I use that caret key, and I would put parentheses around my 1/2. Now, technically, for 1/2, you could use 0.5 if you wanted to, but if it was a different fraction that didn't have a terminating decimal, you could not do it. So 64 to the 1/2 gives me 8. So pause the video, take a few seconds, and type in those other three. Okay, hopefully your answers agree with mine. 64 to the 1/2 is 8. 10 to the 1/2, or I'm sorry, 100 to the 1/2 is 10. 36 to the 1/2 is 6. And 4 to the 1/2 is 2. So is there a pattern? I'm hoping that you can see there is a connection. All of those powers, all of those numbers raised to the 1/2 power is the same thing if I would have taken the square root. So if I would have taken, like in the first one, if I would have done, change this, if I would have done the square root of 64, I would have also got 8. Or if I would have done the square root of 100, I would have gotten 10. And if I would have taken the square root of 36, I would have gotten 6. Same thing with the square root of 4. Okay, so there is a connection that I want you to start seeing with these. Okay, the next one, again, go ahead and pause the video, type those four into the calculator, and see what you get numerically. Again, I hope we agree. I hope you got 125 to the 1/3 was 5, 64 to the 1/3 was 4, 16 to the 1/4 was 2, and 243 to the 1/5 is 3. Now, you may not be as familiar with some of these for that connection of how else we could write these expressions, but if you reference that blue half sheet we've been dealing with, you would see that the connection here, 125 to the 1/3 is 5, but also the third root of 125, that happens to also be 5. And again, if you have your blue sheet, you can check that, or if you want to check that on the calculator, remember the third root is under math. You hit number 4 for the third root. If I type in 125, I should get 5. Okay, and very similar, the third root of 64 happens to be 4, and you can check that. The fourth root of 16, it's a terrible 4, but it should be a 4, is 2. And the fifth root of 243 is 3. So I'm hoping you're starting to see there is a connection between fractional or rational exponents and roots. They are different ways to write the exact same thing. It's sort of like when we talk about multiplying with fractions. And truly, if I had a number and I divided by 2, it's the same thing as multiplying by 1/2. They do the exact same thing, just different ways to write the same expression. And that's what this is. Rational exponents and roots are different ways to express the same values. So do me a favor and type in 8 to the 2/3 in your calculator and see what you get. So again, if I take 8 and raise it to the 2/3 power, you should get 4. Now, hopefully you saw from the other ones that we have done previously, that denominator right here kind of held the key to the root. So if you think of, all right, the third root of 8, well, think about that for a second. What is the third root of 8? Well, I know the third root of 8, and either you do or you can use that blue sheet, is 2. But then the question becomes, how do I get to 4? Well, look at the numerator. If you look at the previous examples we did, all the numerators of the fractions were 1. 1 over 3, 1 over 4, 1 over 5. If this one is 2 over 3, after I take that root, I want to raise that answer to the second power. And again, if I wrote it, it would look like this. And that's where I would come up with a 4. So the connection here, these rational exponents, can be rewritten as roots. The denominator of that fraction becomes the root. If there is a numerator other than 1, then I would raise that answer to that power. So for instance, I'll give you some more mathy terms, if I'm going to do this in general, I would say if I had x raised to the a over b. Terrible. That's the same thing. That denominator becomes the root. And once I get that answer, I'm going to raise that answer to the power that the numerator is. So again, like we saw when we had 8 to the 2/3, that was the same thing as the third root of 8 squared, which we saw was 4. If I had something like, let's go with if I had 25 to the 3 over 2. Okay, that denominator would become my root, so that would end up being the square root of 25, and then I'd have to raise that answer to the third power. Well, the square root of 25, hopefully we know is 5. If I raise that to the third power, I would get 125. And again, if you don't believe me, we could stick it in our calculator. Maybe my calculator works. And if we do 25 raised to the 3 over 2, I do get 125. So yes, our calculator can help us, but as always, I need you to know how to do this stuff because there is going to be some non-calculator components for this test. Okay, so that next part's there, I'm just asking you to switch from one form to the other. So the first couple are in rational exponent form, and then that third one is in radical form, so we want to switch it back. Meaning, if I have x to the 5 6, if I write that in radical form, the denominator becomes the root. So this would look like the 6th root of x raised to the 5th power. Okay, the problem with the next one, number 10, 0.4 isn't a fraction. I hope that you know 0.4, its equivalent fraction, is 2/5. Okay, and then once you know that, then it's easy to say, okay, the denominator is my root, so this becomes the 5th root of x squared. Okay, and then x to the 7/4. Again, the denominator is my root, so this becomes the 4th root of x raised to the 7th power. If I look at number 12, 12 is in radical form. So the first thing I need to do is kind of decipher this radical into a rational exponent. Okay, so if I look at the denominator, so I'm dealing with this radical in the denominator here. The root is 3. There is no additional exponent. So right now I'm looking like 1 over x to the 1/3 would be my fraction. But hopefully you know, anytime there's something, an exponent in the denominator, that came from a negative exponent. So if I want this to not look like this crazy fraction, this would end up looking like x to the negative 1/3. Because we know from our rules of exponents that we looked at a long time ago, that to make this positive, this exponent positive, I would flip it to the denominator. That's what would make it a positive 1/3, and then that radical would become the third root. Okay, so these three, I want you to try. Let me work through 13 with you, and I'm going to have you pause and try 14 and 15. So because this is numeric, yes, you could put it in your calculator. I get that. And you're welcome to put it in your calculator as a confirmation, but I need you to be able to do this by hand because this will be a by hand part of your test. Okay, so the first thing I'm going to do is reinterpret this into radical form. So 2/16 to the 2/3. That first of all means that it's the third root of 2/16, a terrible 3. Still not getting much better. Let me try again. Okay, let's go with the third root of 2/16, and then I'm going to square that answer. So the third root of 2/16, you are more than welcome to use your blue sheet. The third root of 2/16 is 6. And then if I square that answer, that gives me 36. And like I said, you can confirm this right now on your calculator. So you can try 2/16 to the 2/3. Should give me 36. Okay? So take a second, pause the video. You try 14 and 16. I don't know why I skipped number 15, but go with 14 and 16, and then we'll check. Okay, so hopefully we agree. Hopefully you got 9 to the 3/2 was 27, and 81 to the 5/4 was 243. Okay, so the rest, everything you see there on the bottom is properties of exponents. Now, A and B is just a straight review of something we did in chapter 5. Okay, I just started off just basics of remembering exponents, remembering our 3 exponent properties. meaning when I'm multiplying exponents or multiplying variables, I add their exponents. When I'm dividing variables, I subtract their exponents. And when I'm going power to power, I multiply. Okay, so very similar to so many things we've seen lately. These are just cycling back. These exponent properties that we dealt with before have now come back and we're dealing with them again. But if you look, once we get past A and B, everything C through where we are, I at the bottom, all of those things have fractional, or I'm sorry, L at the bottom, my bad. All of those things have fractional exponents. Now, what I need you to know is nothing has changed. All the same rules apply. We're just dealing with fractions. The good news is if you don't like dealing with fractions, meaning you feel like you can't add them, you can't multiply them, you can't divide them, I think you should be able to. But if you can't, you know you can use your calculator to do those things. Okay? So take a second. A and B should be straight review, meaning in A, the first thing we want to do is this power and then multiply. In B, the first thing we want to do is the numerator and then divide. So take a second, pause this, try A and B because those are straight review, and then we'll start talking about some of the other ones. Okay, guys, so hopefully we agree on those first two. Okay, like I said, those are just straight review. Those are things that I think we should know, things that we've done previously, and I think that we should be okay with those. Okay, as we move on to C and all the stuff after that, we now have fractional exponents. Doesn't mean we can't do it. The same rules actually apply. It's just a matter of putting it all together. Okay, so C is actually pretty simple because there's only one thing happening. A and B were way more complicated. In C, I'm multiplying. When we're multiplying, we add exponents. I hope that we know that 1/2 and 3/2 equals 4 over 2 or just 2. So we get A squared. That's it. That one was that easy. Now, if you feel uncomfortable at any point with fractions, then do it in your calculator. Hopefully, just a refresher. If you didn't think that you could add 1/2 and 3/2, you stick it in your calculator. You say 1/2, remember to put parentheses, plus 3/2. You get 2. Okay? So at any point, if you feel like the calculators that the fractions are a deterrent from what we're doing, then use your calculator. I mean, I do think you should be able to do this without, but if you need it, use it. Okay? Similar with part D, I'm looking for the like variables. It's multiplying, so I'm just adding. So I have an x to the 1/2 and an x to the 1/2. Those two x's, 1/2 plus 1/2, just gives me x for the first. Okay? I also have a y to the 2/3 and a y to the 1/3. Add those exponents, I get another 1, so just y. And if you want to put the 1s there, that's fine. Okay, similar with e. E, though, is now switched to a power to power. So you have to raise all of those numbers and variables to the third power. So numerically, if I raise 4 to the third power, that gives me 64. With those variables, remember, I am now multiplying exponents. So q to the 2/5 raised to the third, we're multiplying 2/5 times 3, which gives me q to the 6/5. Again, if you can't do that, use your calculator. R to the 3/4 raised to the third is 3/4 times 3, which gives me R to the 9/4. And that's it. Okay, so take what we know about some of these exponent properties, and I want you to try F, G, and H. Well, actually, I think you can do F, G. You know what? I think you're good all the way to J, and then K and L are a little bit trickier. So go ahead and try F, pause the video, try F through J, and then we can check. Okay, guys, so hopefully, let's check these and let's see how we did. Okay, hopefully for F, you got x to the 6/5, y to the 2/3. For G, a to the 4th, b to the 1/4, c to the 3 over 2, because you should reduce those. And for H, 32, 10 to, or r to the 10/3, s to the 5/4. For I, remember that x on the bottom had an exponent of 1, so 3/2 minus 1 is just 1/2. And for J, again, that m on the numerator, an exponent of 1, so 1 minus 1/3 is 2/3. And you can write that in either way. Now K and L are a little bit trickier. So what I'm going to do is I'm going to save K and L for tomorrow, and we'll talk about this then. So hopefully this made sense, and I'll see you guys tomorrow.